Our final section in this unit is talking about division of polynomials by a monomial. It's also possible to divide polynomials by other polynomials, but we're going to save that for the Math 55 class. So to do division of a polynomial by a monomial is going to look very much like division does with traditional whole numbers. So if you wanted to take 1,642 and divide it by 8, you would divide the 8 into each of these terms, dividing the 8 into 16, subtracting, bringing down the 4, and so on. So we're going to do something very similar when we divide polynomials by a monomial. You're going to divide each term in the polynomial by the monomial, then simplify each term if possible, and if there are any like terms, combine your like terms. And just like with all of our multiplication problems, you're going to want your answer with terms in descending order of degree. So the term with the highest degree first, and so on. And if there are two terms that have the same degree, but they have different variables, put your variables in alphabetical order. All right, math people, creatures of habit. So let's look at some examples of these problems. In the first one, we're dividing 8 into the polynomials 16w squared minus 40w plus 24. So I'm going to do these each as individual division problems. That this becomes 16w squared divided by 8 minus 40w divided by 8 plus 24 divided by 8. When I simplify this term, I'll get 2w squared. This one leaves me with 5w, and this one with a positive 3, giving me a final answer of 2w squared minus 5w plus 3. In our second example, 21r cubed over 7r plus 56r squared over 7r plus 7r over 7r. Simplifying these, remember the power rules. R to the 1 and subtracted from r to the 3 is going to leave us with r squared, and 21 divided by 7 leaves me with 3. Here I'll have an 8 for my coefficients, and an r to the 1 subtracted from an r squared gives me just an r. And then here, just like it was with regular fractions that 7 over 7 meant 1, well 7r over 7r also means 1. So the final answer for this one, 3r squared plus 8r plus 1. And then our final example, 36h squared divided by 12h squared minus 8 divided by 12h squared plus 60h cubed divided by 12h squared minus 7h. divided by 12h squared. So simplifying each of these, my variable terms are going to drop out completely, or the variable part of my term, and 36 divided by 12 will leave me with 3. And this next one, when I reduce, I'm still going to have a fraction. So 4 fits into 8 2 times and into 12 3 times. And then my h, because it's in the denominator, in order to bring it up here, remember the elevator passes from the exponent unit? That h12, in order to bring it up top, is going to turn into an h, I'm sorry, not h12, h squared is going to turn into h to the negative 2. 60h cubed divided by 12h squared will give me 5h. And 7h divided by 12h squared, the fraction part won't reduce, so it's going to stay a 7/12. And h to the first minus h to the second is going to leave me with an h to the negative 1. This one we do have one more step to go, because you'll remember that they say that we want to write our answer with our terms in descending order of degree. So this one has a power of h to the 1. This term has a degree of 1. This has a degree of 0. This one of negative 2, and this one of negative 1. So when I write this answer in order of descending powers, I end up with 5h plus 3 minus 7/12 h to the negative 1 minus 2/3 h to the negative 2. And then one final note on this answer, circling all the way back to our very first definition of what it means to be a polynomial. If I can find that in my stack here. That polynomials have to have positive integers on their ends. So because we have two terms in this answer that are not positive, an h to the negative 1 and an h to the negative 2, just be aware that when you do division with a monomial into a polynomial, sometimes the answer you get is not a polynomial.